Alright, so for today's class, we are going to be looking at Python functions. Functions are integral part of any programming language. So what capacity does function gives to you as a programmer? What does function allow you to do? You know, we have always reiterated that compilers go line by line. It's a common knowledge now. Good morning. So we know that it will go execute first line, execute second line, execute third line. All right. Now there are some codes that we don't want to use immediately. We want to keep for later use, or we want to use them multiple times. Now instead of us to write them somewhere, then when we need them again, we rewrite them. We need them again, we write them again. So what we'll do in that particular instance is for us to encapsulate those code inside a function. We'll put the code inside a function. So that function will be waiting for us. Anytime we need it, we just call the function. Are we here? It's like I know that I'm going to be needing this thing every time. I'm going to be needing this device every time. So instead of me to bring it the first time, keep it where I need it, create another one, put it where I need it again, create another one, put it in another place. All I will just do is to just create this one and keep it somewhere. Then each time I need it, I will just make reference to it. It's just a speaker. The program knows where to go and get this thing and execute it there. So that is the essence of function. Another advantage function gives you is that it makes your code clean. It makes your code easily readable. So instead of we want to write a program that does many things, now instead of us to just be writing the code, just line, so much lines like that, what we can do is we can split those code into different functions. Okay, this function is doing this. I create it, put somewhere. This function is doing another thing. I create it, put somewhere. This one is doing another thing, put somewhere. So that if I want to write my main program now, it's just me calling 3 functions. Did you get it? And each of those functions might contain like 20, 30 lines of code. But it's now easier for somebody to understand because this person will know that I call so function here. Then he will go and look at the code inside that function. So it's going to be easier to understand than just mixing up everything together. Are we getting it? Now, how do we create a function in Python? The key word for creating a function in Python is define. But the short is def for short. So def, then we'll put the function name. What name are we calling the function? So I'm going to call this function let me say count. Def count. I'll call it count. Nice. Now it's going to have a block. Do you remember the punctuation we use for creating a block? If I want to show that this is a block, the punctuation, this sign, yes, the colon. That should show that I want to create a block next. I know blocks are always indented, one indent inside the block. Now anything I write inside this place now is going to be part of this function. Normal, the way we create blocks. Good. So I can do something like this now. Print, let me say 20. Are we there? This is a function that just prints out 20. That's just what it does, nothing more. That's for this function I just create now. Are we here? Now if I execute this line of code now, did you see that nothing comes out? Even when I did printing, even when I asked it to print, nothing. Because there is this one. This one. No, this is what it's actually looking at. The code inside your function is what it's executing. Are we there? The reason why it didn't do anything was because this is a function. I just created a function. I didn't ask it to use the function. It's not going to use your function when you have not asked it for it to be used. Yes, I just created. That's the use of this keyword define. So it is more like creating a variable. You know how we create variable now? Now the Python now knows that it's going to reserve some space in your memory now to put this name, count. Did you get it? And that name will carry that code. So that when I want to use it next, the way we used to call variables, if I want to use this one as a variable, what I'll do, I will just do something like this as a variable, right? Then it knows that count should be this, right? But now if we are using it as a function, we need to use this. This is me calling the function now. Did you get the idea? Let me do something like this so that it will be clear. For variable, if I want to create a variable, say Abdul, I'll do something like this, right? Abdul equal to 5. Are we here? Now Python creates a variable Abdul and assign 5 to it. Now if I want to create a function, Abdul, it's going to be def Abdul. Are you there? Then with this open and close bracket. Now Python will recognize that, okay, I need to create somewhere in your memory for this function. This one now is a function, it is not a variable. Did you get the idea? Now you are going to define a block for it. What do you want it to do? I would just want it to print out my name. Print this is what this function will do. So if I run this, I'm not going to have anything. Let me remove this one so that the name should not. Yeah, I'm not going to have anything. But look at it now. If I decide to call it, if I decide to call the function now, Abdul, watch. Did you see what happened? I created a function. Python recognized this function, creates a space in the memory for this Abdul, for this name Abdul, and that is a function. Did you get the idea? Now I can use this function as many times as I want without having to print Abdul, print Abdul, print Abdul again. If I come down to this place again and do Abdul again, it will still work. Did you get the idea? So anytime I need to print my name inside a function, I can just call Abdul with that thing and it will fire print Abdul for me. Did you get the idea? So it's a modular way for you to write codes. Now let's write a function. Let's write a function that would print numbers from 1 to 50. Yeah, I want to go reiterate what it is that we used in the last class, so that for persons who mixed the last class. So how do we do that? I'll start with the keyword def. What do I call the name of my function? Let me call it iterate. I have this to signify that it's a function. I put the colon. Then what do we do? So how do we remember the syntax for looping? Because I want to print from 1 to 50. It means that I need loop, right? Yes. Did you check the video for the last class? Wow, we did looping in the last class. Okay. All right. Yes, you can use them together. In fact, that is the power of it. You use all these things together as long as they are necessary. This inside the body of this your function just takes another Python code. It can be anything. Did you get the idea at all? It can be anything. Anything can go inside the body of your function. It is just what it is that you want that function to do when it is called. It can now be loop, it can be if statement, it can be creating of variables, it can be anything. Did you get the idea? The essence of this one is just to stop it from running at that time, create somewhere to keep it for you. Did you get the idea? So that if you need it for later use, you can always pick those sections of code back. So it can work for anything that you want it to work with in Python. Are we there? So now I want to print numbers from 1 to 50. So I can say for, right? For I, this can be anything now. It's a variable. You understand this? Yeah. For I in.
Are you sure it can be anything? I was using it yesterday and I was putting something else.
Yeah, it should work. What are you putting? T. Let me have it as T. For T in range, let's say 1 to 51, because it is not inclusive of the last number, right? So it's going to stop at 50. Yeah. So this is a block, right? That I can say print I. Oh yeah. Oh, sorry, print T. Yeah, print T. If I run this code, I'm not going to have anything now.
Okay.
Yeah, because I just defined the function. So, but when I call the iterate now, iterate. If I call the function iterate, yeah, now it now goes back now to now run this function. Did you get the idea? Are we cool with this? Are we cool with this concept? I think the issue is we really don't go over the formal classes, and it is not good enough actually. Because if we go over the formal classes, this is just me adding one line of code to whatever it is that we know before. This is just me adding this one. This is just the different line. Yeah, every other thing here is something we should have seen previously. It can go with if statements too. All right. Are we here? Now I'll create another function, def calculates. Or let me make it def area. Now what would this function do? This function computes the area of a rectangle. Are we there? That's what it is. We know the code for computing of area of a rectangle before. So let's discuss that code. So you know, area of a rectangle, we are going to need length. I'll create the variable length and say 20, right? Right? We are going to need breadth. I'll create it and say 10, right? Then the area is going to be length, right, times breadth. This is actually the code for computing area. Then I can say print area. Good. If I do this now, if I run it, it's actually going to print this for me. Now, how do I convert this into a function so that it can be somewhere, it can be a reusable code for me? Did you get the idea? All I need to do is come up here, define it as a function, def area. Did you get? Put the function sign, then this semicolon. Then I would have this one be part of the block. That okay, all these ones are part of this function I defined by tabbing it inside. Did you get the idea? Now this becomes a function now. It wouldn't execute immediately I execute it. It wouldn't execute. It will wait on my call. So each time I need to compute area now, all I need to do is to just say area. It computes for me. If I need to use it 2 million times, I will just be calling the name area instead of rewriting the code all over every time again. So if I do this, you see, it's executing it for me three times. So this is a much more appropriate way of writing code. And another thing is, I might want to do several other things. Probably I want to calculate the perimeter. So I would define again def. So let me walk through the code for defining perimeter first. For calculating perimeter, I can say this length, right? Would definitely have the length. Let me say length equals to 20. Good. Then I will say breadth equal to 10 again, right? Now perimeter equal to I think is 2 times length plus breadth. Good, yeah. Then I would say print perimeter. Yeah, this is a code that would compute perimeter for me. To make it a function, I will just add the def here, def perimeter, then have it this way, then that's already blocked, then tab it inside. This computes perimeter for me. Are we here? Now if I run these two, nothing. Now the importance is I can write 200 lines of code and probably need these functions at the number 301 line. Then all I need to do is to just call the names there. Perimeter with these two open brackets. This is me calling it. Perimeter is not defined. Okay, I have an error. Now that's 60. So I can keep calling it like that, and that's functions for you. Did we get the concept of functions? All right. Now an important part of function now is every time we are printing the result. There are some times in our program when we don't want to print the result. We want to make the calculation quite fine. You are getting it, but we don't need it printed. Did you know there can be times like that? For example, let me give an example. Probably we don't need the value for area. Somebody is asking us, what is the value for area plus perimeter? Did you get the idea? So I will need my function to calculate the area for me. But I am not telling it to print it out. I just want it to give me the value of the area. Did you get the idea? Calculate perimeter to give me the value. I don't want you printing them out. I want to use them for a different thing. Are you there? So instead of print now, I will use the keyword return. Return is not printing it immediately. Return is giving it to me. So I can say return what for me? Return the area for me. Are you there? Then I would do this one, return perimeter too. Return perimeter. Now see what happens. Even when I call it return, am I printing? What am I printing? It's not supposed, okay. It still prints out though. All right. Now what this return will do is, return will give me my values. So I can choose to now assign those values into a variable if I want to. Did you get the idea? So I can do something like this. Peri equal to perimeter. Do you understand what's going on there? I am telling the program that run this code. You know it recognizes that this is a function because it is seeing these two brackets in front of it. Are we there? Then to go and look for the function. This is the function. Are you here? So it will run this function, length equal to 20, breadth equal to 10, then calculate the perimeter. Then it recognizes that you are not printing. You are returning. So it will send the value back instead of printing. So that value that is sending back is what you are saving inside this peri. Did you understand the idea at all? Anybody gets it? No. All right. Let me re-explain. Are we there? Now this is one section of code that we've defined under a function. This is another section of code that we've defined under another section. They are both waiting on our calls. They are not executing yet. We can execute them. The execution is just keeping them somewhere in the memory like a variable. Are you there? Now, if I call it around there, let me remove this one. Yes. Now, I don't want the values, the computations printed out. I want to take them inside a variable. Did you get the idea? Now, that is the essence of this return keyword. Return is just saying, make all these computations, are you there, and throw out the values back from the function. Did you get? So it runs all the computation, then gives out the value. Now, that value that this is giving out, it is what I'm trying to collect inside this variable. Are you there? It is just like me saying perimeter equal to 3 times 3 plus 2. Do you know the result of this computation? Are you there? Is saving inside the variable, right? Now, this computation is what I've replaced with a function. Did you get it? So when Python gets to this place, it recognizes that, oh, this person is trying to use a function here. All right, it goes to look for that function. Are you there? It performs all the execution, this execution, and you throw out the perimeter. So that perimeter, it will catch it and put it inside the variable. Did you get the idea? If I run this code too, it is not going to print. Why? Because I didn't print, it's just saving it inside peri. Now if I print peri now, look what happens. Did you get the idea at all? Are we following at all? I can do the same thing for area too. I can do area equal to area as well. Are you there? Then this. Then I have a variable perimeter, peri, and area inside my program already. Are we there? Then I can choose to use those variables anyhow I want them. I can do print sum of print peri plus area. Run. Appears confusing. All right, see what happens. Let me go down inside the same block of code now. Are we there? Now, I want to run my perimeter function now and save the results inside a variable called peri now. I will do peri equal to then call the name of the function, right? Are we here? Yeah, it's not all about it, it's the result of whatever it is that you compute here will be here. Sheriff, I'm really feeling your pains. I know you might not get so much from. So I want to run area to equal to area this. Did you get the idea now? So I'm having two variables now, perimeter and area. Did you get it? I can do whatever it is that I want with those two variables now. Did you get the idea? I can work with it like normal variables. Variables are normal. So I can decide to do print perimeter divided by area. Did you get it? So when Python is coming from this place, Python sees this and knows that this is a function. So it saves all this one somewhere. It comes down, sees this, knows that it's a function, saves them somewhere. Now it's coming down here. It's seeing this command, perimeter equals to peri. So it knows that this one is you trying to call a function. You are calling one of the functions that you have created. Did you get it? So it will go back and look for this name, this perimeter name. Did you get the idea? Now this is the perimeter, this is the function that it's using. So it will perform all this computation, and because there is a return there, are you there? Because there is a return, it will try to pick the values of the computation, whatever it is that you return. Are you here? Then save it inside perimeter. Then if we run this code, we have 0.3. That is because it's running perimeter to be, I think, 60, then area 200 and something. That's 0.3. Are we here? All right. Let me give a quick task. Let's see. Yeah. Yeah. No. The essence. Let me use print here, and let me use print here so that you see the difference. Yeah. If I use print here, Print will not throw out the value for me. Print will just show out the value on the console. And that becomes a problem if I need to reuse the values back. See, let me run this and see. Did you see what happened? This is what is happening here. You have defined this function here, and at the end you say print. You didn't ask it to return anything. So it is not going to bother to give anything out back after it finishes the computations. Did you get it? Now the second one to the same thing. Now if I run this code, the first one, I say peri equals to perimeter, right? Now it is going to compute that code and just print. It is not going to give me anything back. So what is going to be inside this peri is going to be nothing. Should we try to print only peri? Let me print only peri so that you see. Print peri. Look, it is none. Did you get the idea? Because I didn't return anything from here. So it is not having a value. Did you get the idea? The same thing for area too. If I didn't use the return statement, it is not going to return a value for me. So if you need to collect them and reuse them inside a variable or something, then you need to tell it to return something for you. Although you can still print and return at the same time. I can do print, then still do return. Return area. Are we here? Or I will say return perimeter. Look at this. If I do this now, then everything works. It prints and both returns. Are we here? All right. I'll give you a quick task. Write a function. Inside your function, define a variable called score. It's going to comprise of the things that we have done before. I want to be checking those things now because it's making the whole class look like they are standalone. The classes are not standalone. The classes uses components from, that's what makes the whole thing powerful. Yeah, define a function called grid. Define a function called grid. The name of the function should be grid. The name of the function should be grid. Now inside the function body, have a variable there. Define a variable score. Define a variable score inside the function body. Make it equal to 90. Yeah, lost. Yeah, if you have a challenge in instruction, just let me know. Let's go instruction by instruction. So add a 90. Yeah?
Oh, 90. Yeah.
Yeah. Are we there? All right. Now check if the score, if the score is greater than 90. Let's listen to this instruction. I want to return a grade for the score, like a student grade for the score. You know, 90 is A. Anything above 70 is A. So if the score is above 70, return, don't print now. Return A. If the score is above 70, return A.
Well, check if the score is greater than 90.
If the score is greater than 70, check. If the score is greater than 70, you are writing it inside A. Check if statements. Have we forgotten if statements? Conditional statements. How to use conditional statements? If the score is greater than 70, return A. Conditional statements. Now to check the condition. Yeah, if score greater than 70. You don't write Python like this. We have not been checking classes. Oh. I know. We are not supposed to forget this statement. supposed to be. So very, very important. If score, the sign greater than. If score is greater than 70, print A. Return A. Remember that A is going to be a string. Yeah, but it's not even installed on your system. So just go to command prompt and type it down. Yeah, then we can use else if, right? Else if grade is, if score is greater than 60, print B. If it's greater than 50, print C. If it's greater than 40, 45, D, 40, E, then else, F. Yeah, are we good? They are not solving the task. Yeah, we would go through the class. Yeah, are we here? Aboki? Anytime. Not too expensive. $100 wow. Not expensive, 90. See you when I will do something now. I will do something. Yeah. Eh? What issue is that? Okay, I'll get problem for that one supervised learning. Problem will choke. The data set is too big. It's too large. 1.5. Just use library. You add a surprise. Yeah, surprise package. Go and check it. Just use it directly because that's what you end up using. Your code no go work. Your RAM no go carry the data set. Anyhow you want put them. Now what you know go still work. Should be carbon at 32 gig RAM. The RAM no go carry the data set. So just use surprise one from ground because you will just waste your time. Then come back to surprise. No, use surprise for that whole project, for that whole unsupervised learning. Just go check. No. It's a Python library for recommendation system. Yeah, just check them out. I think I will use at the long run. With that. But I feel just play around now. They show now small muscles. But at the end, you guys should still fall back to that. Alright, enjoy. Alright, so for that problem that I just mentioned now, I said we should define a function, right? So I'll def grade. Alright. Then said we should create a variable, right? Score, and assign 70 to it. 90 to it. Alright. Now the next thing is we want to use if statements to check what it is that we should return, because that is what a normal grade this thing would do. So if I do if score, this is the syntax for if statement. If score is greater than 70, remember this, then the block. Are we there? Then I will say return. The A is a string. I'm returning A. Are we there? Then I will do elif. This is how to write else if, because we need to pass multiple conditions now. Oh, you did another if inside, right?
Is that else?
Yes, this is how you write. But we did else if in yeah, there's this one. Yeah, there's this one. This one is only useful if the first condition is false, then you just want to return something else. That's we have just two conditions. Like if it is greater than 70, print A, or else print B. Did you get the idea? But most time in real world scenarios, you have multiple conditions that I want to check. I think this should be inside the notebook. It is. I'm sure it is. So just follow along though. This is elif. So this allows me to pass another condition. This is saying else if. Did you get it? So I will now say score is greater than 60. Then return B. Are we here? Then I can now see, because I still have other conditions to check, right? Elif score is greater than 50. Return C. Are we here? Elif score is greater than 45. Return D. Are we here? Elif, I think this is the last option now. No any other one again. If it is not any of this option, then the person, I think there's E too. Elif, there's E. Elif score is greater than 40, then return E, right? Are we here? Then the last option is just return F. That is when we can now use the else that you are talking about. So it's going to be if, elif for the other conditions, then else. Are you there? Alright, then return F. Nice. Are we here? Should I explain this code? Alright. Now, what the code will do is, the code will check this one, create a variable 90. Are we there? Then to use if statement to find what it is that it should return here. Now, when it matches, one thing we should note with this statement is, once it matches one of those ifs, it wouldn't bother going through the remaining if again. Are you there? Because if it matches the first one, if score is greater than 70, if it's actually, it just returns A, it wouldn't bother to go to the next condition. But if it didn't match this one, it will go to the next condition. Check that one. If it didn't match, it will go to the next condition. Check it. If it is not true, it will go to the next condition. That's how it keeps going until it gets to the else. Are we here? Yeah. All right. So now let me use this function. If I now say grade now, if I do something like this, grade, and I print, it's going to print A for me, which is actually correct because my score here is 90. Are we here? Now this takes us to another important section of function. Are we here? Now, if you look at this program, this function is not very useful. Can we identify why this function is not very useful? This function has a limitation if we look at it properly. Yes, it has a limitation. The limitation of the function is that each time I need to compute grade for different score, I will need to come and change this score inside my function. Did you get it? All right, see it here. Let me re-explain this way. Now I need grade now for a student that scored 90, right? Now if I call grade, it returns A for me. Now I don't need the grade for a student that scored 90 again. I want for somebody that scored 70. Did you get the idea? Now the limitation is that the code is still expecting me to go and modify what is inside my function. Probably change this one to 70. No, you don't have that luxury in coding. You don't have that luxury of going back to change values inside your function to reflect. Because what about the other place that have used it before? Do you get it? 5 students, one scored 70, one scored 60, one scored 90, one scored 40, and I need to compute the grade for all of them. Then I want to use one function for all of them. Did you get the idea? Now if I compute for the first person, I do grade for the first person. If I do grade for the second person that scores 60, it will require that I go here to modify this place to 60. Right? Now if I modify it to 60, it's going to affect both of them, because I'm using the same code for everybody. Did you get it? So this is a limitation. It won't allow my function to be reusable in multiple different places. What I'm expecting is that once I create that function grade, I should use it to calculate for any score. Did you get the idea? Without me having to touch the function. Now that brings us to the concept of arguments and parameters. Did you get the idea? They are big names, I know. They are big names. But let's understand how they work. Yes, let's understand how they work. Now this is how arguments work. If I will just pass in a name, a variable into this place, into this quotation, any name, I can make it score here. Are we there? Then I can remove this one. I can remove this one. Now, are we good? Now, this is telling Python that I want you to create a function, but please expect something from me. That thing is going to be score. Did you get it? Now, you can use that variable inside your function like that without even knowing the value. Now, when you now want to come to call it, is when you can now specify. You are telling Python that, okay, you know it before, I asked you to create a function and expect a value from me. Now, when I'm calling you, I'm going to give you that value, so I can give it 90 from here. Did you understand the idea? Did you get it at all? So if I run this program now, it is going to run A. I can still call the same function, grade, and have it being 60. It is still going to work. I can still call the same function, grade, and call it, put 45 there. It will still work. Hello? Confused? Yeah, we don't have 90 here. Now I have given it an imaginary variable here that expects something from me. Did you get it? So it is whatever I pass in between these curly braces now that it is going to take as the score. Did you get the idea? Now the first time when I put 90 there, it is now coming to run this function and say, okay, what is here is 90, Abi. Then to now check, is 90 greater than 70? Yes, return A. That is why this place is A. Did you get the idea? Now it is going to the next one. I call it again and put 60 there, right? It will now go back to the code again. Oh, this score here is 60. Did you get the idea? Now it will now run again. Is 60 greater than 70? No. Is 60 greater than 60? No, right? Yeah, I think there is a mistake with our code though. Did you get the idea? There is a mistake with our code. It has to be greater than or equal to. Did you get the idea? Because 60 is not greater than 60. I want 60 to be, so it has to contain equal to 2. The logic. This is a logical error. Your program works, but the result is not correct. You call it That's logical. So you can go and change some logic inside your program and, all right, this should, because 60 should be B, normal. So if you check this place, is 60 greater than or equal to 60? Yes. So it returns this. Are we there? Are we good? Now let me create another example. Probably this one will be more intuitive. Are we there? I'll create a function called greet. Are we there? I want it to say, now this is printing. Are we there? Print hello. Let's say a restaurant application needs this. And for every customer that comes in, you want to greet them with their name. Are we there? So I'll say hello. If I do hello Abubakar here, each time I call this function, it's always going to give me hello Abubakar. Then the function is not very useful. Did you get the idea? So the ideal way of doing this is telling the function that I'm going to give you a value there, which is name. Now use that value inside my function. Now the function has an imaginary value there, name. Did you get it? So I can use it inside my function. I can say something like hello, then plus name. Do you know what the plus is doing there? I think I explained in the last class. I need to join strings together. Did you get it? If you want to join two strings, like first name and last name, you can use plus to join them together. So it will bring the first string, join it to the second string. Did you get the idea? Now this is a string, hello, and this is going to be a string, name. Did you get the idea now? So if I call this function, let me say greet now. If I call it without anything, it is going to return an error for me. Do you know why? Because it is not, you are telling it that you should expect a name there, and it is not seeing the name. So it's going to tell you, I don't know what I should use for name. But immediately I pass in a string here, say Abu Bakar, and run it. What happened? Oh, I'm using function def. Sorry, it's supposed to be def. Nobody corrected me. Let's still run this one and see if it's going to work. Yeah, it's not working. You see? Now it's giving us a definite error now. Missing one required positional argument, name. It's telling me that I should specify the name. So once I specify name here now, Abubakar, and run it, did you see what happened? It didn't print hello name because it knows that this name now is Abubakar. Are we here? Confused? Confused. Whoa. All right, let me go through the logic, Python logic of this now. How Python sees it. All right? Python looks at it that, okay, this is a function. And you are specifying, you are telling it to expect a name. Now that thing that it is expecting, you can go ahead and use it inside the function. Did you get the idea? It doesn't have a value for this one. Yeah. You can use anything. If I use Usman here, it's still going to say hello Usman. Did you get the idea? It is whatever it is that you pass in here. Because this is imaginary when you first define it. It is just imaginary something. Yes, it's just imaginary. It might not be name, it might be anything. It's just expecting. If I make this place now, I can say this thing should be number. As long as I use the same thing here, Python wouldn't care. Python just knows that I'm expecting an imaginary value, which is called number. Now you can go and use it inside the function, however, how many times you like. I can still use it here, like say print, you are welcome, plus the number, because it's expecting. Did you get it? This is like me saying, I'm going to give you, don't worry. But when I give you, print hello with that thing that I give you. When I give you, print you are welcome with that thing that I give you. Did you get the idea? All right. Now I'm now coming here to say, okay, I'm now ready to call you now, and I'm giving you Usman. Did you get the idea? Because the instruction I gave it inside was print hello with whatever I gave you. And I'm coming down here to give it Usman. So I'm expecting it to say, hello, Usman. You are welcome, Usman, because the instruction inside the function was print hello with whatever I gave you. Print you are welcome with whatever I gave you. Did you get the idea? Even if I'm not giving it a name, Python is not smart enough to know that it is not a name. It just works with whatever I gave it. If I gave it 17, it's going to do the same thing. Did you get the idea at all? One more example. Yeah, let's go for one more example. Let's go for one more example. All right. Def each. I'll still use this example. Def. Let me create a function allow. Are we there? It will only allow it will print allow if you are greater than 18. Then to print you are not allowed if you are less than 18. Let's do this. So normal, I would want it to work for any age. Are we there? So it is not very useful if I come here and define age equal to 18. This is not a very useful program. Because age will continue being 18 inside my program. Each time I want to use it again, would I have to go and modify my program? No. I should just tell it expect, which is what I'm going to do here. Expect a value age. This is me saying I'm defining something. Just expect age. I'm going to give you age. Don't worry. Are you there? Now, I want to use that age now. I will now say if whatever I gave you, that age that I gave you, check it. If age is greater than 18, are we there? Return. I don't want to use print now. I want to use return allow. Are we here? Else return not allowed. Are we there? Now Python will create this code for us inside our computer memory. Are we there? Now with the name allow. Now if I come here now and say, okay, I want to call you allow, I'm calling you now. Do what it is that I've instructed you to do before. I run it. It's going to give me an error that is expecting one positional argument age. I didn't pass in age, and you promised that you're going to pass age when you were creating it. Are you there? So now pass age there. If I say 20 now it understands. Did you get it? It goes to use that 20 inside. Did you get the idea? To go 20 greater than 18? Yes. So it will return this for me. Now, if I want to use for another person, probably another person of smaller age is coming into my program, then 12, I can change it easily. So this allows one code to be used over and over and over again. It makes your whole program very, very powerful. Now, you just envision a code that I'm going to need this thing in multiple places. What your best shot is just define it as a function. And why this is useful in data science is we are going to need to clean data. Did you get the idea? We are going to need to clean data. You have a training data set, you have a testing data set. Are you there? Both data sets are the same thing, but they don't want you to combine them together because they want you to use one for training and one for testing. Did you get it? It is going to be cheating. We don't do that in data science. When you now carry your testing data set, you join it with your training data set, that's called cheating. Because that can influence your overall results. It can leak. Did you get the idea? So you keep both data sets differently. Now imagine that I define functions to clean the first data set. Do I still have to now write another code to now clean the second data set? Some of these functions might be like 100 lines of code to clean the first data set. Do I still need to repeat the same thing to clean the second data set? No. What I would just do is to just write a function that would expect a data set as inputs, and everything that will clean it is already inside that function. Did you get the idea? So if I'm having my training data set, I will just call it on the train data set. If you give me test data set, I will train it on my test data set. If tomorrow the marketing team goes out and get another data set, I will use the same function to still. Did you get the idea? So every time that they are now coming that, oh, we have new data set, I want to start writing function to clean it. Some companies have functions that they've been using for over 20 years. They don't need to, once new things are coming in, they just pass it to their function. new thing comes in, they pass it to their function. So that's the use of function. You already have something somewhere defined that is just expecting data sets. You get, once you pass in a data set to it, it performs that operation. That's the usefulness of functions in data science. So we should know how to use functions in data science. And I'm thinking this is going to be our last class on Python, on introductory Python. And I'm scared right now. we are not checking our previous classes. This thing goes hand to hand. They go together. There's no way you can solve a problem with just knowing one concept. If you know if alone is useless. If you know if, like all you know is if, it is useless. If you know loop as a single entity, then it is not really useful, because all you can do with loop is to just print 1 to 50, 1 to 100. Did you get the idea? If you know function as a concept alone, it is very useless still. But if you now know how the three of them can interplay together, then it becomes powerful. How all these things interplay. Now, let me give you an example of how we can merge all of these things together. Now, I want us to create a function. Yeah? You did data structures the other guy took you through data structures, right? Yes. So the task now is going to be, our marketing team is going to be giving you a list of numbers. Are we there? We want to filter out every number that is not greater than our target, that doesn't meet our target. Did you get it? Probably that number is sales now. Sales for all the representatives daily. Do you get it? Now we want you to identify all the representatives that didn't meet their target. You can do this with Python code. Now I don't have an idea too. That's what I used to say. I don't have an idea. This is just me formulating a problem. And that's what it's going to be like when you are outside there. That is just what it's going to be like. They will just come one time and be like, in fact, even you can reason it. Now, I can actually achieve something with this, but the problem is we are going to need to combine all those things together. Now, how do we do this? You know how a list works, right? Let's say reps. Let's have a list called reps, right? This is what they are giving you. They are giving you something like this: 30, 25, 15, 17, 28, 45, 10, 22, 9. Are we here? Now this is what your program will take. Did you understand this code at all from the data structures class? This is a list. Are we here? Yeah, this is a list. So they are going to give, this is what your functions is going to take. Your function is taking a list. Are we there? Now the task is simple. Print out every value in this list that is less than our target. Let's say our target is 20. Print out every value that is less than our target inside this list. Our target is 20. Now what are we going to do normally? As a person, if I'm working on this list, what would I do? Now this is small now, but this list can be as much as 1 million, 2 million. Do you get it? As a person, what I would have done is pick each of those numbers and check if it is less than or greater than, right? I will check this one. Is 30 greater than our target? Yes, it is, right? I will not print it. Right? Should I leave this task for us to attempt? I think I should start leaving some tasks for us to attempt. Yeah. So this is how I would have done it as a human. Pick the first one, check it, then if it meets the condition, either print it or leave it, right? Check the second one too, like that. Python can do the same thing. We just need to instruct it to do the same. Are we there? How do I check each value in a list? How do I check each value in a list? From the data structure class. I want to pick each value in a list. From the loop class, you can use idea of loop too. How do I check each value in a list? You know, range is a list. So how do I check each value in a list?
How do you check value?
In a list, yeah. Pick out individual values in a list. Exactly. We are supposed to loop through them. Are you there? Looping goes 1, 2, 3, 4, 5, 6, 7, 8. That's how loops work. Now we are not looping through range now. You know, range is a list. But the list we are specifying, our normal loop would have been something like this. For I in range 0 to 50, right? This is what our normal loop would have been like. Now this one, don't forget that this is a list. This is something similar to this one. The only difference is just that this is starting from 0 and it's ending at 49. It's not going to include the last one. So instead of this now, I can replace it with this. Did you get the idea? Eh? Yeah, it's going to work. So if I print I now, check. You see? It is now not looping through 0, 1, 2, 3. It is looping through 30, 25, 15, 17, like that. Are you there? Did you get the idea at all? So this is how we loop through individual values. Are we good? Are we great to go? Now instead of printing now, you know my goal is not to print. What's my goal? My goal is to check them if they are greater than a particular target or less than. Now let's see, let's check. If, are we here? If I is greater than, where's our target? Our target is 20, right? Yeah. If I is greater than 20, are we there? Then I can say return or print. Let me print here. Print I, right? Oh, sorry, I don't want it when it's bigger than. I said when it's less than our target, right? Less than our target. If I is less than our target, print I. That's just it. If it is not less than, I don't want it doing anything for me again. Are we there? So this code should work, definitely. So if I run it, did it work? Yes. These are the numbers less than my target from this. So I can actually use this to pick, if the list is 17 billion, if I run this on the list, it should pick out every number that is less than. If the list is 17 trillion, if I run this on it, it should. In fact, this one alone self is powerful on its own. Because I know Excel will only work for few million rows, few million. Excel cannot load more than few million rows of data. And many of these companies now, they don't work with few millions now. They work in billions of data. Billions, as people who generate data for almost every click on websites, there's data generated. So you should expect tens of thousands or even billions of rows. So this is actually very powerful. Even from, this is a peripheral, but it's powerful on its own like this. This is still peripheral. We are going to use libraries. From next class now, we're going to start using libraries like pandas, numpy. But the problem is all of them still play with this. So we still have to. We'll get to this one. It doesn't work that way. It doesn't work that way. All right. So now, see what I've done here. Now, I noticed that we are always going to have to do these tasks every day. The marketing team goes out every day and come out with list of their performance. So I wouldn't want to be coming to write this code every now and then. So why not define it as a function? Yes? Yes, we can define it as a function. Now let me define as a function. I can do def. Are we here? I want to change this now into a function now. Because I observed that I'm going to be needing it daily. So why would I want to be writing it every day? So def sort filter now. Are we here? Filter. I'll do this. Then I will now expect the list let me say I'm expecting performance. Are we there? Or let me put it as reps so that I wouldn't have to change the code. Did you get this? Then I will tap this one inside, right, so that it will belong to this function. Are we good? Now this is already a function like this. It won't work now except I call it. Are we there? I'm telling this function, filter, I want to create you now with imaginary value. Now, something that you need to know is it is your responsibility now to now know the data type that you are expecting. This is one thing, this is one because Python is not specific. Are you there? Python doesn't know which data type it is that you want to pass here. It's just expecting a name. I'm going to give you value. I'm going to give you a value which is reps. Somebody who doesn't know anything about the function can come here and say filter. Come here and say filter 5. This should give me an error. Did you get the idea? Because I am passing in an integer here, but what it is that I'm using here is a list. Did you get it? So it is your responsibility now. That is why they need the code documentation. Normally, I would provide a comment here saying something like this. This is a comment. We'll come to that later on though. I will say reps is a list. Are you there? So anybody that's looking the code now knows that reps should be a list. Although you look at it, isn't it obvious from the code that reps is a list? Yeah, it is obvious from the code now because the code is small. If you have 200 lines of code here now, then all your variables wouldn't be obvious again. Even you that wrote the code, there's a tendency that you forget the data type of all your variables. Yes. So comments would look. All right. So this is expecting a list now. I can now pass this list that is here to it. Reps. See, does the same thing. I can still pass another different list to it. Filter. I can pass another different list. I can say filter now. If I don't want that first one again, I can pass a list, say 7, 8, 9, 22, 19, 50, 83, and it will still work fine. Oh, what happened? Yeah, full stop, not comma. You see, it still works. Now I'm still passing a list. Are you there? As long as that thing that is taken in is a list, then we are fine. Are we good to go? Now I want to ask us a question. This code that I just ran now, it can still be more powerful. For example, notice here that I had coded the target. What if the target is changing daily? Did you get it? Target might be changing daily. Did you get the idea? What if, do I have to go to change my function, my code every time the targets change? That's another question again. Now the solution to that now is still inside functions. Functions allow you to pass multiple arguments. It allows you to pass multiple arguments. So you just separate it with comma. Where's that filter? So I can pass reps, I can still pass targets. So I'm now telling it expect two things now. Expect the rep performance and expect the target too. Then I can use the target inside my code too as well. Did you get the idea? So anything I pass into this place is what is going to use to replace this place. Did you understand it at all? So I can say the reps performance is this, and I can pass the target to say 10. Did you get the idea? Now, this place is not saying expect one value. This place is saying expect two different values now. Are you there? So if I run this code, it will still work proper. Did you see? So things that your function might depend on might not be 1, might not be 2, might not be 3. They can be 10. Are you there? You just have to pass them in a particular order. Now me, I know now that the first value is supposed to be the reps, right? The second value is supposed to be the target. If there's another thing again, Now let's still do something This is why it is. You can just imagine and just Let me do something interesting again. Do you know that I can still make this function? Instead of looking for underperformers, I can make it look for performers. You know what this function will do is, the function will look for people who didn't meet target. What if we need for people who meet target? Do you need to write another function? You can do that. You can write another function. That will be depending on the skill level now. A novice would choose to write another function like underperformers and performers. Somebody who is skilled can choose to use the same function. I'll just pass another variable there and say, let me call it type. Oh, type is a keyword. I can't use it. That's why it's yellow. Let me call it performance. Yeah, let me call it performance. Are we there? You know why I can't use this type? It's a keyword in Python. Python already used it for something. Yeah, it's used to get the type of variable. So if you call it on something, it's a function. So every keyword that Python has used, you can't use it again. You will see that they change in color. All this def, filter, that you shouldn't use them when you are naming anything in Python again. Did you get the? If not, you are going to override Python's implementation and you are going to cause problem in your code. Yeah. So I can use another name now. So let me call it method. Yeah. Did you get the idea? Now this is me just playing around with things that we have done before though. Now method. If the method is 1, it should look for underperformers. Good. If the method is 2, it should look for people who meet targets. Are we there? Are we following at all? Did we get it? No. This is what, but we understand up to this point. Did we get up to this point? Where I did reps and I put the target as a keyword. Now another thing that I want now is, I want it to either look for underperformers or people who achieved their targets. So I would put, let me add another this thing there, method. Did you get the idea? Now this is what I would now use to control which code it runs inside the function. You get it? I can do something like this. If, just check if it solves my problem. If method is equal to 1, you understand what that code will do now? You understand what this code will do? If method equal to 1, it will check whatever I pass in here. Is it equal to 1? Then I would make it run this code if it is equal to 1. Are we here? All right, let me give a task. Let me give a task so that we can have your hands on. All right? Write a function. Okay? Write a function. Okay? The function will take one price of candy, a cost of 1 candy. The function will take the cost of 1 candy. I will just give general description. I want to make this one as so that it will stimulate our this thing. We can now ask questions and discuss how we'll solve it together. But I want the major part of it to be from you. Are we there? Now this is what I want to achieve. I want to write a program that we can use for a store. Are we there? Now the program is going to take a cost of 1 candy. Are we there? Then the total amount a person is having. Then it's going to calculate how many candies can the person get. Did you get the idea? Like I'm coming into a store now and I'm saying this is 200 naira. Now I am expecting the store to tell me how many candies I can get with that 200 naira. Did you get the idea? You know, first they are going to look at the cost that they sell their own candy. Are we there? Then there's calculations that they are going to make underneath. Then tell me that my 200 naira can only purchase 5 candies. Did you get it? So assuming candy is 15 naira for each one in that particular store. Do you get it? And I'm coming with 200 naira. I'm expecting them to tell me you can only purchase 4 candies. Are we there? But I want it to be a function so that it's going to be universal across stores. So any store can just pick the function and say, okay, my candy is 17 naira. How much do you have? I have 300 naira. Then you can only your money will only purchase 15 candies. Can we try to see if we can solve that problem? Can we try to see if we can solve the problem? Let's just compute. Let's put Python codes together. Let's put Python codes together. Let's add things together. Let's add and subtract. Let's divide and see. Let's divide and see if we can achieve that. I want to see is I want to see a program that I can call on a cost and an amount that I'm having, and it's going to give me the number of candies that I can purchase. That's what I want to see. Let's try to deliver this. We can ask questions. Logic questions. Yeah. But let's try to reason how we can play it out.
Now,
Okay.
we should create a function
Yes.
that
The function is expecting.
it can.
Eh?
It can.
It can.
What I'm telling you is, what you are going to buy is maybe 200 naira.
Okay. That's what I'm having. Me, I'm coming into your store now. I'm having 200 naira now.
To get a particular thing.
Yeah, particular thing.
And meanwhile, you don't know the price.
I don't know the price, yeah.
So we are the one to tell you.
Yes.
To tell you that this is your price. What you have can take you 5 or 6 or 7.
Yes. That's just the idea. But you know, I want that function to be universal. I don't want it to just be one. Because I can choose to change the price of my candy tomorrow. Candy today can be 15 naira, and tomorrow it is 17 naira. I'm not expecting to change that function. Did you get the idea? So instead of defining the cost inside, make them variables. Make them arguments. Did you get the idea? Let's mix this together. Okay. How many minutes should I give for this task? How many minutes should I give? 15? 15? Alright, let me solve this. Then I will give another assignment. Do you get it? I'm not going to do so much explanation. I'll just solve it and expect you to figure it out. Good? This is what my function will look like. I would have def yeah, let me make the function candy. Def candy. Now I'm expecting the price of the candy because that's one thing that our result is going to be dependent on. Yeah. You can make it anything there actually. I'm just using a variable name. So I can say what do I call the amount the person is having? What? Let me call it your what. How much are you what? Okay. So I got the price of whatever we have and how much the person is worth. Are we there? This is as simple as anything. I'll just print. It is actually going to be the worth divided by the price. That's all. Yes, now. Because if you have 200 naira and maize is 50 naira, it's just 200 divided by 50. Yes. Ali?
When we are defining store,
Yeah.
use it in that list form. Not that you. But what I was thinking of is, let's say you define candy bracket.
Yeah.
Maybe price.
Yeah.
Only.
Yeah.
Then now your cost, set it out your price.
Yeah, that's what I'm saying. Okay, let's assume that your methodology now. If I would now have to define price, right? Equal to 20, right? The 20 as your, then what else again are we defining? I think that's it. That's the parameter that we would actually need. Now you define your price now. Now what this means is that if the price changes tomorrow, you are going to need to change the function. And funny enough is that you might have used it in reports probably for yesterday that depend on that function. Imagine I'm coming to change Google's function because I want it to meet my needs today. What about those people that have documents yesterday, that created content day before yesterday? The function is going, because they are still calling that same function, the function is going to affect everything. Did you get the idea? So you don't have the luxury of modifying things inside your function like this. Anything inside your function, you would want to make sure that it is universal across board. So whatever it is that you are sure that is going to be changing, just define them as arguments. That's safer. Did you get that? So I have to define them as arguments such that you can just call them from your, if it changes tomorrow now, it's just me reusing the new value as an argument. It changes next tomorrow, I'll just reuse the new value. Did you get the idea?
Okay, so that means in coding,
Yeah.
the real this thing,
Yeah.
it is this function that works, that you can, once you have it as a template,
Yeah. Yeah.
you have it as a template, so if there's any modification,
Yeah.
you don't need to go back to
You don't need to go back
your
to
source
to your source code. You don't need to go back to your source code. You just in fact, that's the idea of libraries and what they call frameworks. Do you get it? Somebody has written all those codes for you. All you just need to do is to just know how to use them, pass in those values. For example, we are supposed to discuss that in this class. I think that leads us to this place. You see this thing that I'm always using. This thing that I'm always using. Did you note that it's a function? Print. Did you notice that it's a function? I'm calling a function. Did you get it? You notice that two bracket. I'm calling a function. But did you notice that I didn't define the function anywhere? I didn't define the function anywhere. It means that Python has defined that function for us somewhere. Now they are just expecting us to just pass whatever it is that we print, that we want to print. Did you get the idea? Now they have defined, this is what Python would possibly have done. Python have done something like this for us. They have print. Did you get it? Then they now say something like this. Value. Then they've written code, all the code that would make the printing here. Did you get it? Now what we are doing is that we are just calling. I know that this wouldn't work because it's not Python syntax. Okay. What we are doing is we are just calling. I will just call print. Because Python has defined, I don't need to know what Python writes. Normal. In fact, in the normal workplace, once you write your code and it's working proper, anybody that's using it don't need to bother themselves about what it is that you wrote. All you need to do, they are going to trust you as a developer. Your code has been well tested. All you need to do is to just tell the persons that what my code is accepting is any integer, any string, any value. And once they pass that into your code, they are expecting it to work. In fact, sometimes as a developer, I might call my friend that I need a function that would do, I don't need to rewrite. Do you get the idea? You can just send me the function like that. I wouldn't need to go through the whole code again. Just tell me what I need to pass into that function and what I would, and I'm fine with. As long as you trust it that it worked for something, it should work for me too. Did you get the idea? So these ones, the functions that Python has already built for us, they are called inbuilt functions. You don't need to bother yourself with it. Just call. Print is one of them. This function, do you know this function? Int. Oh, you are not seeing it. int that we used to use. We used to use, let me use one that we'll be more familiar with. Input. You know, we'll call input with that to, as long as you are putting that to this thing, it is a function somebody has defined somewhere. Did you get it? So now Python has defined that one for us as a function. That once you call that function now, it's going to bring out that box for somebody to enter any value for us. Did you get the idea? That's one of it. Another one again is int. You know, we used to put int around the input so that to convert values to integers. This is what I'm talking about. You know, if I put this now, do you know that this should work? This should convert, this 5 is a string, but I'm telling Python to convert it to an integer. Did you get it? That int itself is a function that has already been defined by Python. Python knows that you are going to need all these things every time, so they don't want to bother you with writing all those low level. It is not one line of code that will do this. In Java, to do this, you might write like 15 lines of code. So Python understands. It already gets somewhere. Okay, let's do all those sub-level code for this person. You just call. You just say int. Did you get it? And now this one is an argument that Python has already defined there. Did you get it? Are we there at all? All right. Okay. I think my function should work. But one other thing now. One other thing. This wouldn't work as expected because this can give us floats. For example, I have 19 naira and the price of the product is let's say 13 naira. You know, 19 divided by 13 is going to give us something point something. You can't tell me I'm going to get 13 point something candy. So I should convert this to an integer, right? So how do I convert this to an integer? You know how we do it? We wrap it inside an int. Did you get? Eh? You understand this? What is going to come out normally is, okay, let me make it easily understandable for you. There's many ways to do this thing. I can do candies. I can do total equal to this. You know it's still going to work. Right? Did you get it? This is going to work. I collected the division inside a variable first. Then I can now do print int total. Exactly. Is it? It has scattered, right? Let me re-explain that part so that you get it. But you know what this code will do, right? Eh? You understand what this code will do? The code will divide whatever it is that you pass in as a what. It will divide it by the price, whatever you pass in as a price. Are we there? And it will save that inside a variable called total. Are we good to go? Now if I print this now, I'll print total. Now let me run this so that we can see the problem why I need to add that int. Now let me use this candy now. Alright. Now let's say for that particular store now, the cost of one candy is 13 naira. Are we good? That's the price of the candy. Now somebody is having 200 naira. Did you get? Now the person is telling us how many candies can I get if I run this now. Did I print? Yes, I printed total. Why is it not printing for me? Why is it not printing? Kilo divide. This is strange. Oh, this is strange, yo. There's a print statement there. So what's going on? Eh? It's not bringing out anything, and I'm surprised. Well done, sir. This is very, very strange. This is very, 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 very strange. I'm coming. Coming, let me see. I didn't return, so I'm not expecting to see anything yet. So what's going on? Let me refresh probably it's my editing that is misbehaving. It's not bringing anything for you too. Why? Total equal to what's going on? What's going on? I printed now. Define candy. Okay, let me change this thing to compute first. I'm coming. I want to just debug where the error might be from. 13, 200. Lord have mercy. Let me see. Return total. But I'm printing. It's working when I'm returning. It should work for print too. So what's the problem? Print does. Ha! What's going on? What's going on? What's going on? I'm coming. Let me debug. I use this tool for debugging most times. ChatGPT is a very lovely tool for all this. Normally, we used to use Stack Overflow because I wouldn't understand why it's not printing yet. So. Oh. Alright, before that response, let me use return then, since return is working fine. Return total. See me, what's up? I'm good. Yeah, you go where? Would they expect you? Yeah. So you never come out house? I'm on the way. Yeah, it's raining. Alright. Yeah, now take care. Alright, let me still work with this one first. Now, this is where the problem is. I'm telling the person that it's going to have 15.33338 candy. Why is it having 15.33338? It should just be you can have 5 candy, you can have 10 candy, you can have 15 candy. What is the essence of that 15 point? Now, this number here is a float. Did you get it? I want it to be an int. That's why I'm putting that int there. I'm converting it to an integer. Did you understand the idea? That int is an inbuilt function in Python that has already been designed to do this kind of thing. So if I do this, you see, it's converted to int directly. Did you get the idea? Yes, now. Still the same thing. So why is it not working? When you run compute, you should Control V. Let me see. It's not printing. It's shocking. This is actually shocking. I really don't know why it is not printing, but it should. The lines of code is not much. From looking at it, you know that there's no error there. So, all right. Another task now. I seriously want us to get this problem solving with Python. Another task. Let me reason it out. Okay, let's look at this. I'll give you. It's going to be challenging. Okay, this is the problem statement. This is the problem statement. I will give you the energy level of an athlete. I'll give you the energy level of an athlete. Are we there? I'll give you the energy level of an athlete. Then I will give you the amount of energy. Are we here? I'll give you the amount of energy the person loses each time the person jumps a particular block of code. A particular, let me make this, let's assume we are looking at I jump. Are we there? We are looking at I jump now. And I will give you the amount of energy an athlete will lose each time the person jumps a pole. Are we there? If you jump a pole, you are going to lose this particular amount of energy. Are we there? Then I want you to give me how many poles will the athlete jump. So I can give you the athlete's energy level. I'll tell you this athlete has 200. I don't know the unit for energy. This athlete has 200 in terms of energy. Then he's going to lose, let's say 20 when he jumps a particular pole. Then how many poles can that athlete jump? That's what I'm expecting you to return back for me. Are we here? Can we attempt that? We are still going to modify that to make it more complex. So let's try to attempt that. You have the initial energy level of the athlete, and the athlete will lose a particular amount of energy for every pole. Now tell me how many poles will the athlete be able to jump. Let's say the energy level is 1000, then you are losing 20 after you jump every pole. Then how many poles can you jump? So you have an initial energy level of an athlete, then the amount of energy is going to be losing per jump. So how many poles can the athlete jump? So for example, I gave you 200 as the initial energy level. Are you there? Then I'm telling you that it's going to lose 20 per jump. It's expected that that athlete should be able to jump 10 poles. Do you get it? Because if you jump the first, you lose 20. You jump the second, you lose 20. You jump the third, you lose 20. Then you should be able to jump maximum of 10 poles. Did you get the idea? So that's the task. So is it complex? Eh? Wow. It follows the same logic with this one. Just the same thing. Eh? It's similar with this one. It's just the same thing. Let's just reason it out. If you can reason it, you can achieve it with Python. If you can reason it, just tell me normally without Python. So what would you have done without Python? So if I'm telling you now that okay, we're having an athlete, and I'll give you the initial level of the athlete, and I'll give you the amount of energy is losing per jump. Now what would you have done to get the amount of poles without Python? Yeah, I think without Python, what I will just do is I will just divide the initial energy level with the amount of energy is losing per jump. Yes. I will just divide. Now, another implementation is, that's why I'm telling you that all these things are not static. Another implementation is, do you know that I can use loop? I can use loop, yes. I can just be looping. First, I will minus the first 20. Go again, is it less than? I will minus the second 20. Is it less than? I will minus the second. But as I'm going, so I'm keeping track of the counter that I'm using. Did you get the idea? At the end of the day, I will just print the counter for you. That's another implementation. So all these things are not static. Or somebody would have choosing to do it like that. Somebody will say, well, I will start minusing. I would minus, I'll do 1, minus, do 2, minus, do 3, minus, until that's still fine. That is still a solution. Yeah.
There is
no universal approach. Just reason it.
Depends on your understanding and what you know, how to make
Each of these things.
what you will solve.
To the same problem. 5 of us might do different implementation. Our differentiating factor will now be how efficient is the code going to be. This solution now is a constant solution. We'll call this O of 1. It's constant. The resources doesn't change. Did you get it? If the person you should tell me that the person's energy is 17 billion. The resources I need to compute it wouldn't change. Because I'm just doing 17 billion divided by its energy level. So this code will be way faster than whatever it is that you want to do with loop. Do you know loop now? If I tell you the person's energy level is 17 billion and it loses 1 per jump, then you are going to lose loop 17 billion times. Did you get the idea? Now let's reason that in time of efficiency. Is that really efficient?
Another thing I'm thinking now,
Yeah.
the mathematics, when you get into the real,
Yeah.
your mathematics must be
Very sound.
sound.
Uh,
Because if let's assume what's perfect,
Yeah.
I've written it down in mathematical form.
Yeah.
So I can now translate it if I'm able to
Do.
get it in mathematical form.
Yeah.
So that is I can translate it.
To Python. Yeah, sure. And that's why most times, in fact, computer science majorly steps out from mathematics. Most universities that run computer science, they branch it out from mathematics. Yeah, most of those principles relies on mathematical concept. But now it is not really important that necessary for you to understand the internal implementation. It is just necessary for you to understand how each of those components play out.
It's necessary because when you work over price,
Yeah,
if you don't understand
the mathematics behind it.
basic algebra,
Yeah.
you might not know how to
Yeah, basic mathematics is necessary in every field. Because even in accounting, something like this, it is expected that that somebody gets this. But the sweet thing with it is that as a programmer in an organization, most of these things comes with research. Did you get the idea? My initial research would have been, how would I solve it in person? Do you get, if a management is giving me a task now, okay, I'm going to do a task for this company now, I'm expecting that you specify, how do you get your cost? How do you get your this thing? How do you get your amount? What the company should have all those formulas normal. This is how our cost is the division of so parameter by this parameter. This now your own work as a programmer is now translating that idea. Yeah, that's what normally they will call domain experience. If you don't have the domain experience, it's going to be hard for you to and majorly you just think that my work is just coding. Why are they asking of clinical experience from me? Why are they asking of accounting experience from me?
that means at the end of the day,
Yeah.
someone is able to do
Yeah.
you have to focus on the task.
Yes. That's why they stem it out.
Python, whether you
Yes. You see business analytics, financial modeling, all those things they step out because they want to look at secluded areas, and even inside AI itself, you see them stemming them out every now and then. You have computer vision, you have natural language processing, you have generative AI. Once they see that you require a different skill set that is domain based, they will just stem it out. Did you get the idea? So that they will allow some particular set of people to focus on that area. Generative AI is still normal computer vision, but they require that you are going to need more experience on art work because you are picking style from here, joining it to another style. So they stem it out. This is generative AI. Did you get the idea? Okay, financial modeling. You are going to need so much of finance, calculating amounts, dealing with it. They stemmed that one out as financial modeling. Now we have health intelligence, health analytics. That one now you are going to need to deal with health parameter. What is the insurance? How do you get the insurance computation? How do you get the claim? All those ones is another branch on this. So they keep, but it doesn't mean that one person cannot be. We have persons who've worked on projects across years, across board. Yeah.
So is there, can you recommend like a test
Okay.
that has all these basic things?
Yeah. Okay. That has introductory Python, right?
Yes, all these basic things.
Introductory. Yeah, I think I would send to the group. Yeah, I'll send that to the group.
So that you know if you read with
What is yeah, check it again. Yeah, I would send that. So I will look for a video compilation, somebody that takes introductory Python, then I will look for textbook too. Yeah, I will look for both of them.
but if I read textbook again,
You get
I can easily
relate with whatever it is. All right, there's no problem. I will send the textbook. I will send the textbook to the group. Okay. There's one that I use. There's one that I use like that. Total is not 200 divided by 20. But the problem now is you are coding these values inside. It won't work. You are defining a function. You can't pass values into your function definition. You get? This is expecting variables. You can't pass 200 and 400. Okay? It's going to. Not going to 200 by. You get it? Yeah. It should work. Yeah. The no space between print and the bracket. Therefore, the formula is that the one. You put space, atlet, no space between those brackets. Yeah, because they are atlet and the bracket. So, yeah, that's it. There's also no space between them. And then you make it up. Remove the print that is off of it. Yeah, that's it. It's not the print to pass. Convert the output into that. So that's the closing parameter. Can you convert the output into that? That's the inside of the function. Convert inside of the inside of change. You will modify the function. It works. Yes, I think that's okay. But your output is float. I want the output to be bigger. Yeah. This one you cannot pass it values. When you are creating the function, you use names. You cannot pass it values. So it should be use names there. It cannot be like energy, something like that. You never conversion it's inside your function that you convert to. You can't convert inside your function. Whatever the things you are doing has to be inside your function. So you convert has to be there. You can convert from there. And you can say create a variable, you can convert it to variable complex. Anyone that wants to. Yeah. So any modification that I do has to be inside your function definition. All you do with your function call is just call it. Yeah. All right. I think we have that working. Now let's do this again. Let's do this. I'll still challenge our this thing again. Now the person can take. Are we there? Is it working now? Yeah, so that place now will not be energy loss. It will be 220. So it's not anything that will pass here, that will work here. So change this one to energy and loss. You don't use constant values like that inside your component. Alright. I want a condition that if the person takes okay, this is going to be task over. I'm still going to give you. I'm not saying on task. If the person takes what do they call this energy boosters? Glucose, that's what they call it. Glucose. If the person takes glucose, per sachet of glucose, the person is gaining, for one sachet of glucose, the person is gaining 50 energy back. Now I'm going to give you the number of glucose that this person will take. Then you still give me the number of moles the person can drop. I'm going to do that. So we know that per glucose that you are taking, glucose gives you 50 energy. Are we there? Now if I now give you the first part that this person has so amount of energy, then he's losing so amount per jump. Now it's going to take 10 glucose along the line. How many poles do you think you can jump? Let's try to modify it and see how we can. Let's try to modify this. Let's see. You can just play along with the logic that, okay, like this. Then try to see how we can convert it to code. Okay, you work? Yeah, that will work. Now let's call the function. We call the function as writing the name of the function. We can access so that's inside the function. Now it's inside the function. You know, you have tab. You have two tabs. So it's inside. Put the effect. That's not outside the function. Now you can call the function. Nice. In the brackets. Okay. Now let's say we have energy level of 200. Then we have loss of, let's say, 20 loss. And then click on let's say. Yeah. Wow, okay. Now another problem now is they have chance to take glucose, and glucose adds 50. Glucose adds 50 to their energy. So per glucose that the person is taking, the person is getting 50 additional energy. Are we there? So I'll give you the number of glucose the person will take. Alright, let me say the logic. Let me give the logic. Mathematically, if I do it like this, I'm going to be correct. Anybody can do it anyway. But I think if I do it like this, I'm going to be correct. If I multiply 50 by the number of the glucose, I should get another set of energy. Then I can add that energy to what they gave me before. Yes, that should work. That's going to be faster. It's just one line of. Although you can do this another way, because you've gotten one set of energy. You can still do that for that glucose and still divide again. You get? Yes. You can do what? It's two ways. This is one of the ways. This is one of the ways. I have initial energy. Initial energy, right? Then I have the amount that is losing. Right? I can do initial energy. I can do initial divided by loss to get the main energy, right? The main number of poles. This is without glucose. Are we there? Without the glucose, now I can compute this first. Then I cannot compute with glucose again. Let me now say energy with glucose. I can say glucose now. I can do this equal to how many glucose did the person take? Let's say 5, right? And it's going to give me 50 per 1. Did you get it? Then I can now say divided by the loss again. To get how many poles the person can jump with glucose. Do you understand? Normally the person can jump, let's say 20. Now glucose is now giving the person additional 250 again. I can still do divided by the number of poles again. Confusing. So did you get my implementation? I was trying to say normal. I can check without glucose, eh? Yes, additional energy. Yes, by the you know, let's assume that the person first exhausted his main energy. You know, we have the amount of pole the person can drop with his main energy. Now the person is already down. Now, but from taking glucose again, the person gets additional energy. Did you get the idea? We can still compute the amount of poles the person can jump with that additional energy. That's what I'm doing there. So this person gets, that's 5 times 50 is how many? Let's say 250, right? And is losing 10 per pole. It means that the glucose will still allow the person to take 25 more poles. Did you get the idea? Confusing. So now, alright, this is it. Alright. Let me say, which one would I, okay. My energy, each of this will take, each of these things will take me 10 energy. Good? To work with each of these blocks. I would exhaust 10 energy now. To go from 1, 1, 1, 1. Good. And I'm starting with 20. But somebody tells me that if I eat corn, are we there? If I eat corn, I'm going to get 10 more energy. Are you there? Now, my initial energy will take me 2. Right? That is what I've calculated here. That's initial energy divided by the amount of. Now I'm here now. I'm exhausted now. Now somebody now gave me 3 corn. Did you get the idea? Now if I eat that 3 corn now, I'm going to have 30. Did you get the idea? That's what I did here. I multiplied 5 because I'm giving the person 5 glucose times the energy of the glucose, which is 250, right? Now that 30 will allow me to move 3 more. 1, 2, 3 more. That's what I computed here because I divided by the loss. I want to check how many more the person can move. Did you get the idea? Yeah. So I now get the main energy by the main number of poles the person can drop with his main energy, by the number of poles the person can drop with glucose induced energy. So our total now is going to be total energy equal to main plus glucose. This implementation should work. Eh? Oh, you did 2 different functions. I want the inside out. I want the inside out. Yeah. Alright. That's the implementation I was trying to explain. Now let's look at that. I'll just do it peripheral. Let's look at that. The athlete. This is my own function. So I'll do energy, then I'll do loss. Are we there? Then I'll do number of glucose. Are we there? Are we paying attention? Right. Now the first implementation I will do now, I will do something like this. Poles, number of poles, main energy. How many poles can I jump with my main energy? Did you get it? So I would have energy divided by loss, right? This should give me the amount of poles I can jump with my main energy. Did you get the idea? Now let's now go again. Are we there? Now let's say poles, glucose energy now. glucose energy equal to, are we there? So I will now do glucose, the number of glucose, right, times 50. That should give me the total energy that glucose will give me. Did you get it? It means that I now have a new set of energy now. I can now compute the amount of poles that I can jump without my new energy, which is going to be divided by the loss. Are we there? So this is going to be another energy. Yeah. Are we getting it at all? This is a new set of energy now. The one glucose just gave me. Are we there? Then I'm checking the amount of poles that I can jump with it. So that's going to be what's going to be poles, number of poles in energy. Then I can add the number of poles for the two together. Yes. So if I can jump 15 poles with my normal energy, I can jump 3 poles with the energy that glucose gives me, then every pole I can jump should be 17. Are we there? So I can just do print. I can just do print poles main energy plus poles glucose energy. Nice. This should give me it. So if I'm calling this function, I will just use atlet. I would have energy. Let's say my initial energy is 700, right? And I'm losing 50 per jump. And I now take 10 more glucose. So how many? Why is this thing not printing now? I'll still have to use return. Okay, return this. Run. So this person can jump 24 poles. Is it actually logical? Yes. Okay, let me work with a value that is logical so that we can check if our program is correct. Let me say the person has 10 and the person is losing 2. Let me change our glucose level to 2. Energy glucose gives you now is 2. Where? Yeah, no, this is the energy the person is having initially. This is the energy the person is losing per jump, right? Now this is the number of glucose the person takes. The person takes 1 glucose. Are we there? Now if I run it, the person is able to jump 30 poles. Why is the person able to jump 30 poles? Why is this person? I didn't rerun this one, okay? Yeah, 6 poles. That's because if you look, 10. How many poles can he jump with his normal energy? 10 divided by 2, which is 5 poles, right? With his normal energy. Now the person takes 1 glucose, and that 1 glucose gave the person 2 more energy. And each pole is 2. So it means the person can jump 1 more pole. Are we there? So the number of poles becomes 6. Very intuitive and correct. This is one way of doing it though. I still have another way of doing it, but I wouldn't go there. There's still another way of, I can actually add the glucose energy to the initial energy. Then divide everything by number of poles. That will still work. Eh? look at, you reason my program intuitively, you see that the program is correct. Now, let me just run the other method directly so we can see. Now I can choose to do it another way. This how I would have done it the other way around now. I would have said all energy, something like this. All energy equal to my the initial energy I'm starting with plus I said glucose will give us 2, right? 2 times glucose, the number of glucose. Did you get this? This will give me the energy glucose is giving me. This is the energy glucose will give me plus my main energy. Did you get this? So I should now have a total energy now. So with my main energy and the energy glucose will give me, I have a total energy now. Now, then I will now get number of poles. Poles now is equal to all energy divided by loss. Print poles. This is still under implementation. Nice implementation actually. Let me return. This thing is causing me nuisance. Nice implementation, the same answer. So what it is that I did there is that instead of me calculating the number of poles individually, I just joined all the energy together. They are both the glucose energy with my major energy. I joined everything together. They are now count the number of poles and jump to the combined energy. That's another implementation. Another person will do this. Probably somebody will come and do it in one line. Yeah, depends on the expertise. And it doesn't really matter. As long as your code works and there's no loophole, like there's no visible loophole in terms of speed. The amount of memory you are consuming, your code is fine. Nobody has the right to tell you that you are supposed to do this way or that way. And nothing can all be different. So I can do it this way, I can do it the other way, and I will submit the same code and nobody can tell me that one of them is. Because if you check, both of them are actually efficient. Yeah, the other guy is coming for one more Power BI class. But the rain is actually different from that is raining over his head. Yeah, so more tasks. More tasks. Okay. Let's see more tasks. Let's see more tasks. If I have a list of now this I want if your function I'm going to give you a list as the argument or parameter as the parameter for the function. If I do this one, I'm just going to okay. Okay, print all the numbers, print the differences between a number and the subsequent number. This is what I mean. I'm going to give you a number now. Print the difference between the number and the subsequent number. Do you understand that? Like, if I give you a list of numbers, let's say 5, 3, 9, 4 now. You look at 5 and 3. What is the difference between them? You print it out. Can we do that? Yeah, let's try. The input to our function. The input to our function is going to be a list. Are we there? Now we look at that list now and print out the difference between if the number I'm considering now is 5. The next number after it is 3. Then what I'm printing out is 2. Then I'll now go to the next number. That one is 3, right? And the next number after it is 7. Then 3 and 7, what's the difference between them? That should be like 4. Then I'll print 4. Then the next number is 7, right? What's the next number after it? 5. 7 minus 5. That should be 2. I'll print 2. So like that. The difference between a particular number and the number that follows it. Can we print that? Can we do that? Now our logic is that we are actually, let's look at the logic because, you say? Alright, let's look at the logic. That's the first place to always start from. Converting it to Python code is just to be. Now, the logic is going to be that we need loop, right? Are we there? Do we know how to get each value in a loop? Yes, we know how to get each value in a loop, right? We know how to get each value. We did it not long ago. So if I give it a loop now, like 5, what is my marker? I'm coming, let me check it out, okay? Yeah, I think this person complicated our markers. Yeah. So if I'm having, I gave you the input, your function is 5, 9, 3, 2, 8. Do we know how to look through each element of this? You can look through them. Yeah, you can look through each of this, right?
What I will start with 0, 0, 1, 2, right of that. And now follow the next number, maybe start with 1, follow that.
Exactly. I think that's what we need for this particular solution. You see, the initial loop that we did now might not work for this one. Because if I do for I in this, let me say this is R, right? If I do for I in array, right? You know, I is going to be the individual elements inside this. How do I now get the next element inside? Do you get it? Let's say my I is 5 now. How do I get 9? So that I can minus them together. Do you understand the idea? So this implementation would not work. But I can do something like this. For I in range 0. Wait, data structure. Do you look through the list in data structure? You look through list in data structure, and then you must have done this in class. So let me do it. So just follow. I would explain the code. I would explain what code I use for. So I'll do something like this. Let's say the list we are considering is I can't use list. List the keyword. Array equal to 2, 7, 9, 6, 4. We are using this, right? I want to loop now. I can say for I in range 0 through length of array. Do we understand this? Do you understand it? Yes, exactly. Yes, exactly. See what that code is just doing. Yeah.
Let's say I want to call that number 3 out.
Yeah.
Something bracket there, 0, 1, they just enter, bring up.
Yes, but you know we can't pick out individual like that manually. Did you get the idea? Yeah, I can do something like this. Array 0. I can now do something like this array 1. I can do array 2. But the problem is, if I give you this thing 1000, are you going to do array 1, array 2, array 3, array 4, array 5, array 6 inside the 1000? And don't forget that the function I want to create is changing. The number of elements that we need is changing. Somebody can pass 5 elements. I'm expecting your program to work. If I pass 7 elements, I'm expecting your program to work. If I pass 20, I'm expecting your program to work. If it is well defined, that I'm going to work with 5 elements only, then I can do this. I can just start. I know I'm going from 0 to 5. I can just say array 0 minus array 1. Array 1 minus array 2. Array, because I know that I'm just using just 5. Did you get the idea? That's why I'm saying some of... Yes. Now, if I give you 100, are we going to write 100 arrays inside? Even if it's not plenty, even if it's just 2, 3. But because it's changing. Did you get the idea? Somebody passes in 2. Another person passes in 3. Another person passes in 1. And we are all expecting it to work. So you can't use this fixed implementation. But it is very lovely that you know that this will work. We are going to use this inside this program. That's what we are talking about. All these things combined together. Did you get? Now, this is the implementation that I am proposing. For I in range, you know what range you do? Yeah, I'm saying start from 0. Are you there? Now go towards the length of this, whatever the person passing. Did you get the idea? Yes, it has given it an open end. Do you know what this length will do? The length will just print let me print what the length will come outside. You see? Because array here is 5. If I make array here 9, 20, if I run it and I come here and run length of array, do you see what happens? It changes to 7. So depending on the amount of arrays the person is passing, the length will be returning a different number. That length function is an inbuilt function in Python that is meant to calculate how many items are inside your list. Did you get it? That's the first thing we need for our program to work. In fact, go self. How many things are inside that list? Did you get the idea? Well, I told you before, there are many ways of this. If you are going to be comfortable, you can do it like this. Length equal to length of array. If you are going to be comfortable with it like that, then you can now pass this one as length. Is this still the same thing? Yes, still the same thing. Because I just collected the length of the array inside the variable here. Then I passed it into this. So if this length is 7, it's going to be from 0 to 7. If it is 20, it's going to be from 0 to 20. Did you get the idea? All right. I'm going down next. Now, what do I implement? Okay. Between 0. Yes. You are slicing. That's a slice. You want to get all numbers between 0 and that particular distance. You are cutting an array. Did you get the idea? You are not looping the array now. You are cutting. Like for example, let me use that here. Array 0 to 5 wouldn't loop through it. It will just say, okay, I'm not considering this whole array again. I'm starting from here and stopping here. Look at what it will give me. Did you see that it cut the array? It stops here. Yes. Did you get the idea? You are slicing it. Did you get? Sometimes you might not want to consider the whole array. Did you get the idea? Somebody just tell you that the top 10 people are executives. Probably it's an instruction from you that they are not sales personnel, but all their records are still inside that data. So I'm not expecting to consider top 10 people. So what I will just come here now, I will just say start from 10. Slice it from 10, and if I want you to consider the whole thing, I won't put an ending. I'll just say start from 10, go to the end. So it will just slice out. Yeah, from 10 to slice it out, then to consider the remaining. Did you get the idea of that? So that's a slicing on it.
So if you want to bring down the comma, not the...
Yeah, not semicolon. Yeah. So that one now would go 1, 2, 3 like that. Yeah. Are we there now? All right. So what do I do inside this loop now? Do you get? You know, I have access to a counter now. I have access to something that is counting from 0, 1, 2 to the length of the array. Are we there? So I can now do something like this. I can do something like this. First value. Like seriously, if you look at it, you find out that I really don't have the implementation. There's no need for you to have a crammed implementation. Do you get it? As long as you can just, first thing, I want to pick the first value, right? Then pick the second value. That is what I would want. Are we there? So I will say first value equal to array I. Second value equal to array I plus 1. Do you understand what I did there? Let me explain. Do you know that I is going from, this I would go from 0 to the number of items you have inside the array. Are we there? So I can just say the first value is going to be the value at that position I. Let me illustrate on the board. So this is what I'm saying. For I remain 0 to length of, this is going to be 1, 2, 3, 4, 5. Now this is going to be 5, right? By this array that we pass in here. Are we there? So I now said first norm equal to array I. Are we there? Second number equal to array I plus 1. Let's see if this solves our problem. Now I propose this now. We can evaluate if it solves. Now I'm saying I'm getting my first number, right? Equal to array I. Don't forget that I is going from where to where? I is going from where to where? 0 to 5, right? So the first time I is coming, now I will be 0. Good? So this one is going to be array 0. You remember how we get that thing that you mentioned that time, that we just put brackets and the number we put it, we just fetch out that number. So it is going here to fetch this one out. Did you understand the idea? You know, normally if I do array 0, what will array 0 give me? What will it give me? It will give me 5 because 5 is in the position of 0. If I do array 1, what would it give me? It will give me this. If I do array 2, what would it give me? 3, right? It's the same thing I'm implementing here. I'm just using my counter here as a kind of position pointer. Did you get the idea? So if it's going the first time, I is going to be 0. Then my first number is going to be array 0, which is 5, right? Now my second number, I'm not saying don't do I plus 1. What's I plus 1 going to be? I plus 1 is going to be 1 because it's 0 plus 1, which is 1, right? Then it's going to come here and pick this one. Did I get the normal number and the next number? Did you get the idea? I can manipulate this value when I want. I can decide to say I plus 2. I can decide to say I plus 4 to get the 4 number after it, to get the 5th number after it. So whatever it is I do with this I, it's depending on what I want to achieve. Do you get the idea? Are we good? Confusing? Confusing. Alright. Well, let me explain.
I plus 1.
Yeah.
The output for I is 0. For I in range 0 to length.
Yeah.
And if that means you are saying that you are defining I.
Yeah.
From 0 to
yeah.
length, and our length, length is number.
Yeah, length is number. That's why I put 5 here.
We define length ARR to be 1, 2, 3, 4, 5. Okay, 5.
Yeah.
Which is 0,5.
Yeah, you get it. And don't forget that loop goes 1, 1. Remember, loop goes 1, 1. Loop doesn't go 0 to 5 at the same time. It will go the first time when I is 0. So that first time is going, I is just going to be 0. It will go again. I now is going to be 1. Now when I is 1, what happens? My year is going to be array 1, right?
What will now be the value of that first value? ARR with bracket.
When I is what?
ARR.
Yeah, when I is 0. Let's assume we are going the first
That means
time.
we have to specify another thing for I to get that second.
The second value?
Yes.
Yeah, that's why I do I plus 1.
But when you implement it,
It will.
if it is giving
Error. No, there's something. It's not the logic now. Once you have an error, it doesn't concern the logic. It's now about the syntax, how you arrange the. Yeah, doing equal. Okay, there's an equal to it. And the I plus 1, first number equals to this. Okay, at least you just have to bring. I understand. Yeah, I understand. I was planning on addressing that, but you wouldn't understand it if you didn't. If I just do the solution to that without the explanation, that's why I did it for the first time. Now see what happens. Let's do this manually. The first time I is coming, you know I can do this now. Print. This gives me my program. This is what I want. Print first number minus second number, right? This is my whole program. Now let's go now. What this will do? The first time I is coming, the first time the loop is running, my I will be 0, right? Are we there? So in that phase now, array I, this is going to be 5, right? So first number will be 5. Are we there? Now what is going to be my second number? It's going to be I plus 1, right? Which is 1. That's 0 plus 1, which is 1. So my second number will be 9. Are we there? So I'm going to print 5 minus 9, which is going to give me 4. That's the first time the program is running. It's going to print 4 for me. Are we there? Now the program is coming back again. My I is going to be what then? 1, right? Did you get? Because it's going from 0 to 5. So yeah, 1 by 1. That's how a loop works. That's how a loop will work. Whatever it is that you pass through inside there is going to go through that thing. Did you get it? 1, 1. Are we there? Now the next time my I will be coming, my I is going to be 1, right? So I'm going to say array, my first number is going to be array 1, right? Which is going to be this. Right? It's going to be 9. My second number will be array 1 plus 1, which will be 2, right? It's going to be this. Did you understand it? So it's going to be 9 minus 3. The second time is going to be 9 minus 3 is 6. Are we there? Now the third time, the same thing. Are we there? The third time, I is going to be 2, right? So this is going to be array 2. So it's going to be this one, 3. Are you there? My second number will be 3 plus 1, right? Which is 4. It's going to be this one, like that. Are you there? But there's going to be a problem. That's where he is having issues. Because I'm looking from 0 to 5. Are we there? My last one wouldn't have a next element. Did you get the idea at all? That's where you are having issue. The last one here wouldn't have, because I'm going from 0 to 5. The last element, my I is going to be 5. Right? Oh, sorry, my I will be 4, not 5. Because it's going from 0 to 5. It's not going to reach 5. It's going to be 4 for the last one. Now, my first number is going to be 0, 1, 2, 3, 4, which is 8. Are you there? Now, my second number is 4 plus 1, which is what? Which is 5. Now, if you come here and say array 5, 0, 1, 2, 3, 4, 5. No 5. That's why it is giving us error for your program. Did we get it? So there's no difference between the last one. So the best solution is to exclude this last one, because there's no way we can compute a difference for it. So I think instead of looping through the entire length, we should loop through the entire length minus 1. Did you understand it? I'm getting the length of the array now. Then I'm looping through it minus 1. Do we understand at all? I think we need one to do all this problem solving. Yeah. I think that's what the next class is meant to be. Yes. Okay. So I think this place is just for you to just add, instead of this total length, just add minus 1. Do you get? So this place is going to be the length of the array number. Then it's going to be minus 1 for it, so that it won't reach. Yeah, it won't reach there. It didn't work. You didn't call it. Okay. No, there's no function there. Yeah, it didn't print. Okay. Okay. Alright, let me implement it for everybody to see. Now, can you convert it to a function such that it's going to take universal arrays? You can take any array. Try to convert that program to a function. Yes, convert it to a function. Let's see. So that it don't just work for one particular array. You can use it for multiple. So, alright. So, my final solution will be print first value minus second value. Okay. Yes. Then I'm putting minus 1 here. Do you know why I'm putting do you get why I'm putting minus 1 here? Because I don't want it to reach the end, the last one. You know, this length of array will give me the length from 0 to 0, 1, 2, 3, 4, 5, 6. It will give me 6. Did you get the idea? But I don't want it to get to that last one, because if it gets to that last one, it's going to give me an error for my program. So I'm now minusing 1 from it. So if it's 6, just give me 5. If it is 7, give me 6. If it is 9, give me 8. If it is 20, give me 19. You get, so that will prevent it from reaching that last one. So we would avoid having error in this regard. Alright, so if I run this, I think I should get a reasonable program. Well, I still have an error.
The first line.
Yeah.
LENGTH.
Okay, yes. Is it from here? Is it from here? Let's see. Yeah, I think it's run. But this is not, my print function is not working. I've not been having use for print since. Alright, let me convert it to a function. I will just return the value. So I will convert to a function. I will have def. Are we there? Def, let me say difference. Then I would have it get an array. Are we there? Then I will just cover, then make all this one part of the function. Nice. Then instead of printing this, I will return it. I'll return it. I think this is nice. So I can choose to now call my function with any list that I want. So if I do difference, if I do 2, 7, 4, 9, 15, if I run it, I think I should have a good answer. Why is it giving me just 1? I'm having a problem with my, yes, I'm having a problem. I can't use return here. I'm still going to have to explain this. Yes, I'm still going to have to explain this. How do I explain this scenario? This is one logical error. The problem there is I'm using return. Once your program comes in contact with return, it doesn't run any other thing again. It just believes that it has gotten to the end of that function. That's the problem there. Did you get the idea? That is the problem that this is having. I come here, you know I'm supposed to be looping. Finish the first one, go to the second one, finish the second one, go to the third one. Yeah, but I have a return there. This return is just telling the function that throw away whatever value it is that you have and stop. Did you get it? So I cannot use return here. Do you know how to add something to a list? Eh? Do you know how to add to a list? You did it in dictionary data first. So I can do that. Let me define a variable called result. Result equal to this. Append, exactly. Do you get it? So as it's going, instead of me to be returning as I'm processing like that, because I know that if I use return, it's going to stop my function immediately. So I should append it to another array. Do you get it? So I'm going to do result. Are we there? Result dot append and put in that value inside. I'll put first value minus second value. Did you get? Do you understand what it's going to do like that? It's going to run the first time, append it to the array, run the second time, append it to the array, run the third time, add it to the array. So now after everything, I can now return it. Do you get it? This return is not inside the for loop now. Did you get it? The for loop will complete before it comes to this return. I can now return results. If I do that, I should have something even more solid than what it has. So my solution is now more solid than yours. Because now I'm having my solution in an array. I can choose to reuse this elsewhere. But that one, that your own is printing out the solution. So you can choose to collect those solutions inside the variable. Okay, another problem. Last problem. Next class, we are going to solve programs next class. I think we are calculated with this, just solving, using them to solve problems. And I think people are getting in more with the problems and the explanation part of it. Okay? All right. Okay, let me give you a simpler one now. I'll give you a simpler one now. Define a function that will take a list. I will not make it that simple. If I say you should filter out numbers that are even, that's going to be simple. Okay, you define a function. Are we here? Then you have another parameter, filter. That filter is going to be any number. Are we there? Then just print out all the numbers that can be divided by the filter without remainder. Do you get it? Your function will take in a list. For example, I'm giving you a list 5, 7, 9, 12, 13. Are you there? I'm going to give you a filter. Let's say the filter is 2. Did you get it? Your task now is to print out all the numbers inside this list that this filter can divide without remainder. So if you say 7 divided by 2, it's going to have remainder, right? Then you leave it out. You go 12 divided by 2, it's going to have remainder. It's not going to have remainder. You print 12. Did you get it? Let's attempt. Should I re-explain the problem? Huh? Alright. The problem is, we want a function, are we there, that would print out all the numbers in a list that is divisible by a filter without remainder. I.e., let me give an example. I'm having 20, I'm having 5, I'm having 4, and I'm having 13 as the first parameter. Then my filter is 2. Are you there? I'm giving you this list and I'm giving you this filter. Sometimes this problem statement they sound big, but they are simple implementations. Now I'm giving you a filter of 2. Now what we need to do is you print out all the numbers that this 2 can divide without remainder. So if you check 20 divided by 2, is there having remainder? No. You print out 20. 5 divided by 2, is there having remainder? Yes, you leave it out. 4 divided by 2, is there having remainder? No, you print out 4. 13 divided by 2, is there having remainder? Yes, you leave it out. Did you get the idea? So you just filter the number by this filter that I give it. So you know your function is having two arguments now. The array and the filter. Can we attempt that? Yeah? No need of the numbers. Just write the function that will. Okay. Yeah, just write the number. You know that your first argument is a list. Then the second argument is a filter. So that information is enough. Is is what I'm saying. We need the function argument. So we checked argument just now. Argument is like how would I put this one? Imaginary value. Your function is expecting it. So you mustn't have the number while you are defining the function. You get? All you need is the name of the what we have here now, like this one. It's something like this. Okay. This is an array. This one is expecting an array now. Are we there? So your own function too should be expecting an array and a filter. Did you get? Now note that that filter is an integer, a number, not an array now. So you are having an array and a filter. So what can we do with that? The system went off. So please, for our next class, I will send the material. Please, wherever we can read it to, we should try to read it, because the next class is just going to be problem solving, and it's not going to be very nice if we start explaining some of this concept again. We now start. Yes, the textbook material. I will send the textbook material to you. I'll send it. So the area of concentration there are operators, the data type, conditional statements, and for loop and functions. Those 5 places. Just try to revise through them. Those are what we are going to be using. So we are going to be using a platform that has different problems on them, and the problems are not like this one. So it's not going to be nice if we start looking at integers, we start looking at loop, we start looking at float again. We would want to believe that we understand what loop is doing. So if there's anything we'll be talking about, it has to be something that we've not probably discussed before. Let me show you how the platform looks like. It contains problems, contains wahala. Yes, it's a nice place to test your skills.
From your experience, what are the major things that we should get to know very well?
Yeah.
The operators, the data.
Those 5 that I mentioned. There are several other things in the materials too, but just understand the operators, the conditional statements, the data types, then the for loop and functions. Those 5. I think those are what we took in class. There are others. There are classes. But they are not as frequently. You hardly use them in this aspect of programming. So those parts are left out. So. Yeah. This place you see problems that you can use when you are a beginner. Problems that can give you nightmares. They are all here. So we are going to be looking at solving. Once we can pick problem from Akara and we can solve those problems successfully, put it on. Once you can pick a problem and we don't need to go intermediate. We just need the beginners. We don't need to go intermediate. We don't need to go. Once we can solve the beginner's problem from Akara, we are good to go. Let me log in and see. I think I don't remember my password now. I think it's because it's logged in on my other device. Yeah. Accept. Okay. So there's interview preparations, there's competitions. Yeah. Alright, so I can just filter this one like to go easy. But even the easy are enough to enough to, yeah. So not all these are related to what we want actually. So I would filter out like 20 to 50 good ones that we are going to be using, kind of problems that we are going to be using almost every time. So I'll filter those ones and we'll look at them in the next class together. See an example of a problem here. See what a problem statement looks like. This is an example of a problem. Did I solve this one before? I'll just change my language to Python. You see, problem statements just looks big. They will look big, but given an array of integers and a positive integer k. Given an array of integers, now it means that we are expecting something like this. Array equal to this. They are going to give us this. That's what they mean. It's similar to what we have been doing. They are going to give us array of integers. This is an array. Integers. Integers are just numbers. Given an array of integers and a positive integer k, then they are going to give us k again. K is something like this. Let's say 9. So we're having these two. Given an array of integer and this. Determine the number of pairs where I is less than j and ar plus j is divisible by k. Now this is a condition. Now this is a condition. So you see an example. They will specify an example there. They are telling us that the array, if the array is 1, 2, 3, 4, 5, 6, and the k that they are giving us is 5, 3 pairs meet this criteria. The criteria they are looking for is, they say where I is less than j. Where is I? Where is j? Okay, where I is less than j. Okay, and ai plus aj is divisible by k. Alright, now the condition is that, are you there? The first one has to be less than the second number. Are you there? And when you add both of them together and you divide by k, you should not have remainder. I think that is what we have just done in class. I think with what we did in class, we should solve this problem successfully. I think I tried this problem, so I didn't get it before, but with what we did in class, we did it in two lines of code. This code is handy, this one. That's particular code. Alright, we'll do it next class will be a class for next class. That will be class, that will be. Yep. The problem like this now, are we able to get it? No. So that's, I'll let that go as an assignment. So I'll put it back. Yeah. I'll send it. So I'll send the notebook for this class. The textbook will come immediately. That textbook is very, very, very handy. But what I didn't know how easy it's going to be for you to comprehend it, but it's what I use here, what I use for. The number of pages are too much. Yeah? Yeah, definitely. Oh, are you in the group? No. I'll add it to the group, so I'll push it to you. Yeah, it's on WhatsApp. I'll push it to the WhatsApp group. Yeah, the email for the classroom. But on the better on the classroom. I think it will be better on the classroom. I'll have it on both of them. And for anybody that prefers videos,
WhatsApp group, I don't use WhatsApp group.
we have the WhatsApp group now. It's just because people have not been asking questions. That's why I didn't remember that we have WhatsApp group. Eh?
No, I don't have WhatsApp group.
No, you are in our WhatsApp group now.
The WhatsApp.
Eh?
The WhatsApp.
Okay, yes, yes, yes.
I remember I sent some challenges there one time. Only few persons responded to. And those kind of challenges are some of the things that just keep these basics. Just keeps the basics fresh. Because at some point, you might not have to do much with the basics again. You might not have to do much. So when you enter NumPy and all those things, you might not have to do much with the but they are still. Looking at the problem. You see 3 pairs meet this criteria. 3 pairs. You look at the 1 and 5, 1 and 4. If you look at 1 and 2, 1 is less than 2 though. But if you add 1 plus 2, that's 3. 3 divided by 5 is not possible. That's why they didn't add 1 and 2 there. Did you get? Now if you look at 2 and 3, 2 and 3 meet the condition too. Because 2 is less than 3. But we add 2 plus 3 is 5. 5 divided by 5. They say it must be divisible by k. 5 divided by 5 should work. Yeah, they have 2 and 3 there. Do you see? So one on the outside is 2 and 3. Now if we now look at it, 3 and 4. 3 plus, this condition works because I is less than j. The first one is less than the second one. Are you there? So 3 plus 4 is 7. But 7 divided by 5 will have remainder, so they give it. Now look at this. 4 and 5. 9. 9 divided by 5 doesn't exactly like that. Now they are not doing it for just one permutation like that. They are doing it for all the possible permutations. Did you get it? So they will do 1 and 3, 1 and 4, 1 and 5, 1 and 6, 1 and then they will now come again 2 and 3, 2 and like that for all the possible permutations. Then they are now checking it. Is the first one less than the second one? Yes. If you add both of them together and divide it by 5, is it possible? Yes, then they will print it out. So that's the problem. Huh? You said?
I said it will have the answer like 1 and 5.
You just?
1 and 2 cannot go.
Yeah.
1 and 3 cannot go.
No.
1 and 5 can go. 1 and 4 can go.
Yes, 1 and 4 because it's 5. Yes.
Then you go for 1 and 5.
It cannot go because 1 and 6 cannot go, yeah.
You drop that.
Yeah.
Go to 2.
2, yeah.
2 and 5. 2 and 3.
Yes.
Can
like
go.
that. Like that.
Then 4 and 5 can go.
Now that is what they are expecting you to do now. It's not left for you how you are going to implement it with whatever language you want to implement it with. That's less for you now. That's less for you. And once you can be able to solve some of these problems successfully, then I think we are ready for data science. Yes.
Okay, so we don't want to do data science.
I'm not working with it like data. I'm just coming up with the introduction of how to do the process. That's why it's a Python program. But at the end of the day, many of these things come out with cheating. It's just something that you don't look at and you don't need any mental processing to it. Once you understand what you are doing, it just comes up.
It goes down to practice.
That was exactly what I told you this morning. That so just boils down to how long you can. But imagine that you have implemented this for 3 different problems. Yes, the problem that requires something like this come outside, you will know that no, I was trying to do something like this and I do something like this, it works. So it's going to be easier for you to not stretch out something you use for this problem, print out something you use for this problem, mix them together and get solution on that problem. That's just how these things work. I know I've solved something that deals with remainder before. How did I do that deals with remainder? I know I've did something that worked on looking through individual elements before. How did I do it? Now if you combine all those together, I'm going to solve this problem. You see? That's just linear algebra. I don't know the other tutor. Yeah, I think that one is supposed to be part of this class that's coming to now like this. Space part.
Is it far from the is not
Lagos.
Traffic at
The time. The time for this thing, so I don't have the time to do it. Next week is compared to the weeks, not after weeks. I think pandas. So the Power BI class is gone now. We are now using Python as a library now. We think it's purely coding for next class. So that's this one is actually. So how far we pass that?
So you don't pay money for it.
I will go to straight dashboard. If I say create the dashboard now, I said you have one challenge that time. Can we create something 5 days, yeah, they are both, I think they are.
Yeah.
Because what this one is giving us now is giving us 8 individual days and a number of games. Yeah, exactly. So they are going to be, if we have 1,000 days now, so I'm going up to 1,000 days. They are going to have 1,000 of these different colors. You get the idea. What this one is used for is just a very that doesn't have more than 3 different values inside. Like for example, now that this set space now, we have been very used to this is something like no. We just did Python. He has said that you should just sleep. But I feel like the class is yeah, it's this thing go. I didn't stop the recording.
You guys did conference?
Yeah. I hope we are able to recall the things we learned. Though. We have gone far though. I hope we are able to use